All right. So now we're looking at graphing the polynomial graphs. And so these ones are super fun. We just need to find the x-intercepts. And so the x-intercepts are just when I set each of these to 0. So x minus 3 is equal to 0. So 3, which is right here. And then the other one would be at -1. The interesting thing here is that when we have that exponent of 2, that creates a bounce. So right here, I'm going to have it facing like this, and then it will pass through there. So we just want to remember on these, when we have the multiplicity of 2 on one of the roots, that creates the bounce shape. And then this is quadrant 1, which is the positive quadrant. So whenever we have a positive a value, we're going to end in this quadrant. We also want to talk about end behavior. So here's the x-axis. We've got negative infinity. We've got positive infinity. So we talk about what happens as x goes towards negative infinity. So as x goes towards negative infinity, what's happening to the arrow for y? So I see that the arrow on this half of the graph, right, on this half, is pointing down. So as x goes towards negative infinity, y goes towards negative infinity. On the other side of the graph, that's on this side, as x is going towards positive infinity, what's happening to y? Well, the arrow there is pointing up, so y is going towards infinity. To make this really, really good, I also need to find the y-intercept. So these two, these are intercept form, so that's really nice. So just to find the y-intercept, I'm going to plug in 0. So that's going to be 0 minus 3 squared times 0 plus 1. So that's going to be -3 squared, 9 times 1. So I could have actually made my graph even better. I could have gone through 9. So this is the best graph. Oops, should have done that to begin with. So we'll do that on 53. Of course, on 53, we don't want to forget about this little guy. That little x is x equals 0. And then each one, x plus 1 equals 0, x plus 2 equals 0, and x minus 5 equals 0. So I would subtract 1, this is -1, this is -2, this is +5. So I've got 1, 2, 3, 4 values. So 0, 0, that tells me my x-intercept is at the origin. And so that's the x-intercept and the y-intercept in this case, which I love. So then I've also got -1, got -2, and then I've got +5. So counting this up, this is a 1, 2, 3, 4th degree. And remember, fourth, they go in the same direction, either both going up or, well, maybe both going down, like for a parabola, up versus down. And so I see the negative sign, which means I definitely want to be in quadrant 4, a negative quadrant. And so let's trace this. None of these have a bounce, so I'm just passing right through them. This looks great. So again, we'll look at the x going towards negative infinity and then positive infinity over here. So as x goes towards negative infinity, I can see that the y value is also going towards negative infinity. And then on the other side of the graph, as x goes towards positive infinity, here's the y value on this side. It's also going towards negative infinity because the even degree means that the ends, both of the arrows, point in the same direction. So if I was just looking at the equation, I could see, oh, that's 4th degree and it's a negative a value. So that means to me that both of the arrows would point down. That's enough information for me to talk about the end behavior. Since they're both going down, the answers here are both negative infinity. Now in 52, if I look at that equation a little bit more clearly, I can see, okay, in 52, this one has 1, 2, 3. This is a third degree. And third degree with a positive A. So that means that the arrows point in opposite directions. And there's one arrow in quadrant 1, and then the other arrow is in quadrant 3. And so thinking about that, maybe sketching just a graph that looks just like this, I can see that as x is going towards negative infinity, the y goes towards negative infinity. But then as x goes towards positive infinity, we can see that the y, well, my arrow is a little bit messy. The y arrow points up, so both are going to positive infinity. So with the odds, the x and y both go in the same direction, negative infinity, like we see here. These are both negative infinity, and these are both positive infinity. So that's really cool. When we have a positive A, the infinities match for odd degree. Whereas with an even degree, the infinities for y, they're going to match, and they're going to be the same as the A value. Negative A means negative infinity, but if it had been a positive A, we would see positive infinity. Let's move on. Oh, not that far. We're moving on to just solving equations and then writing equations. So solving these equations, we're looking back. Okay, so these are all single variable equations, just solving. So balance the equation. That was supposed to be at the equal sign. So I'm going to subtract 12. That's going to be negative 35. That's 7x. And then dividing by 7. X equals negative 5. Okay, on 55, I'm going to add 3. It's going to be 11 is equal to x over 6. And that's x divided by 6, so I times by 6, giving me x is equal to 66. Students hate problems like 56. I'm going to times both sides by 12, which is just 4 times 3. That way the 3 is going to cancel with the 12 and make 4. And the 4 cancels with 12 to make 3. That's how the cross products get together. So this is going to be 4, but you've got to put parentheses around this and this. So x minus 3, and then 3 parentheses x plus 4. So once we put those parentheses, that's going to remind us we use the distributive property. Don't forget to multiply to both terms. So that's 4x minus 12 is equal to 3x plus 12. And then I'm going to add 12. And that's not 0, that's 12 plus 12, that's 24. Since that, I'm also going to minus 3x. So that would be 1x is equal to 24, so x is equal to 24. Ran out of space on that one. So number 11 is really sneaky. I've got that negative sign here. So remember, I have to distribute first. So whatever is right next to the parentheses, distribute it before you do any other work on some of these problems. So 11x minus 6x, then change the sign plus 5 is equal to 25. Now that parenthesis is no longer needed, and so I can combine my like terms. This is 5x, and I'll subtract 5 is equal to 20. And then I divide by 5, and I get x is equal to 4. Oh, circling my answers. So again, on 58, we have to distribute first. And that gives me 4 times 3, 12x plus 4 times 4 is equal to 6x plus 8. This one seems kind of weird because they're so similar. So I'm going to subtract 6x. And I need to make sure that I put my numbers on one side and x on the other. So if these are the x's, I want the numbers over here. So that's 6x, and then this would make -8. Dividing by 6, I get a fraction answer. X is equal to -4/3. So looking at 59, we got to make some space here. Wish I could just zoom more. Okay. So 59, we've got an equation with variables on both sides again. So I want to make those positive. I just prefer that. So since I moved the x's to the right, left-hand side, I'm going to add 15 to move all the numbers to the other side. That's going to give me 8x is equal to 26. Dividing by 8. I get another fraction answer, dividing both of these by 2, 13/4. Cool. So the rest of these problems, it looks like, are absolute values. Let's take a look at these. Remember, absolute value is a distance from 0. So on number 60, we're saying, okay, the number inside here, whatever this ends up being, this 2x minus 36, that has a value of 14 units from 0. So it's either going to be 14, of course, or it's possible that 2x minus 36 was equal to -14. And then when you evaluate it in the absolute value, it became positive. So we find both of the answers. So I had 36. I changed it to 33. We had 36. It gives me 2x is equal to 50 and x is equal to 25. That's one of the solutions. Do the same work over on this side. I add 36 and I get 36. It's actually 36 minus 14. So I get 22 is equal to 2x. And then I divide by 2 to solve. So if this had been an equation that was like y equals absolute value of blah, 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 just like we did in our unit 3 test, make sure to plug in 0 for y. Okay, so 61, I can tell looking at it, I need to isolate the absolute value first. So when I subtract 7, this problem is just kind of a waste of time. I get the absolute value of q minus 3 is equal to -5. But remember, we said absolute value is distance. Distance is always measured in positive units. Even though we create a negative answer, we create that after it's equal to a positive only. So this one has no solution. So now we're done. On 62, we again want to isolate the absolute value symbol, but to do that, we just divide by 8. Hi, Caitlin. And so dividing by 8 here, we are going to have 2b minus 3 is equal to 8. Hello. And then that creates the two possibles. 2b minus 3 is equal to 8. And 2b minus 3 is equal to -8. Solving both of those, I add 3. And I have 2b is equal to 11. And then I add 3 here. And that's -8 plus 3, so I get -5. And I have 2b is equal to -5. Both of those divide by 2. And that's how I get my answers. B is equal to 11/2. And also -5/2. So I just finished working on the absolute value equations. And now I'm going to move on to the inequalities. So it says here we want to solve and graph each inequality. So let's get started. On number 63, I see the 2 there, and I'm going to distribute that. So I've got 15x plus 25 less than or equal to 2x minus 8. Then I see that 15 is bigger, so I subtract 2x on both sides, just because I prefer to have positive variables. So if all the numbers are going to be on the left side, that means I'm going to subtract 25 to put all the, to put all the numbers on the other side. So that gives me 13x less than or equal to negative, adding 25 and 8. I think I get 33. Yep. So now I divide by 13 and I get this fraction answer. X is less than or equal to negative 33 over 13, which is just a decimal. If I was going to graph that, I would use a closed circle at that decimal value, and it would go towards negative infinity. All right, looking at number 64, I'm going to do the same type of work, but here on this side, the 8 is more x's, so I'm going to subtract 7x on both sides. Since I'm canceling out the x's on the left side, I want all the numbers there, so I'm going to add 2 at the same time. That's going to give me negative 7 plus 2, negative 5 is less than x. Oh, this one was way better. So this one, it's preferable to write x first. So x is greater than negative 5, because then we'll read it the correct way. And so when I would graph that one, I would start at negative 5 with an open circle, and I would go towards positive infinity. It's got to be at negative 5. All right, and then I've got a little bit of mess over by 65, so I'm going to clear my work. Are you okay with that? Goodbye, work. So 65, I've got that fraction proportion there. So I'm going to multiply by the least common multiple of those denominators, which is actually just 8, because 8 is going to cancel out 8. And 8 also cancels out a 2. So the 8 cancels out the 8 all the way, leaving no denominator, and that's just 5x plus 1. And then the 8 cancels with the 2, but there's still a 4 left over. And 1 times 4 is just 4. So this one now looks really nice and easy. I'm just going to subtract 1. That gives me 3. And then here is still 5x. So dividing by 5, I get x is greater than 3 over 5. When I go to graph that, I have an open circle, and I go greater than towards positive infinity, and I would start at 3 over 5. Very cool. Let's look at the next page. Okay, so now we're back in unit 3 for fully. It says solve each quadratic equation. Make sure to use each method at least once to practice. Okay, so I'll practice 66 with the completing the square pattern, since that one has an a value of 1 and then an even b value. So I'm going to add 33 to both sides. And then I'm going to do the work of completing the square. The special number that I'm going to add to both sides, I like to just put a blank there, just it makes me feel good. So it's from the formula, it's b divided by 2 squared. That's the special c. for completing the square. So this time that's going to be 8 divided by 2, which is 4 squared. 4 times 4 is 16. Now I can write this as x plus b over 2. And so if b was negative, it would be x minus b over 2. So this is going to be a plus 4 squared is equal to 48. Now I can solve by taking the square root of both sides. But because it has an exponent of 2, I need to make sure to put plus and minus on the square root. And I get a plus 4 is equal to, so 48 is 16 times 3. Taking the square root of 16, that comes out of the radical as plus and minus 4 rad 3. Finally, solving for a, I subtract 4, but it does not combine with the 4 that's already there. I get a is equal to negative 4 plus or minus 4 rad 3 as my answers. Great. On 67, I see a GCF of 5. So I'm going to divide the entire equation by 5. I can do that with a number. I don't want to do that with a variable because then I'll lose one of the answers. So that's going to be x squared minus 25 equals 0. And this is the super fun factoring of x plus x minus, and don't forget to take the square root. So it's x plus 5, x minus 5 equals 0. And setting each of those equal to 0, I'm able to solve pretty quickly. So I just add the opposite. I get x is equal to positive 5 and negative 5. So I just say plus minus 5. So I'm looking over here at 68 and I see that 66 and 67 were equal to 0, but 68 is not equal to 0. And I know that that's step 1 to solving these types of equations. So the first thing that I need to do here is subtract 14. So I've got 3b squared plus b minus 14 is equal to 0. And I'm going to go ahead and use the quadratic formula here. A is equal to 3, b is equal to 1, and c is equal to negative 14. And the quadratic formula says x is equal to, so it's going to give me the solutions, negative b plus or minus b squared minus 4 times a times c, all divided by 2a. So it's going to be x is equal to, a is 1, b is 1, so negative 1 plus or minus 1 squared, that's just 1 minus 4 times 3 times negative 14, all divided by 2 times a, which is 2 times 3, 6. And so inside the radical, I have 1. The 2 negatives change this to a plus. 4 times 3 is 12. 12 times 14. So it's 144 plus 24. 168. Oh, this was factorable. I get 169. And the square root of 169 is a number. It's just 13. So I have to do the calculations. I've got x is equal to negative 1 plus 13 over 6. And then also negative 1 minus 13 over 6. So negative 1 plus 13, that's 12 over 6, which is equal to 2. And then adding negative 1 and negative 13, I get negative 14 over 6. So that means my other answer is going to be negative 7 over 3. So b is equal to 2 and negative 7 over 3. I could have written that a little bit smaller, but that was super fun. And it was nice to see how when we have a number inside the radical, like 169 or 144, a number that comes out a square number, we have to do this extra work. We've got to finish and get those numerical answers. All right, let's see a few more. We've got 69. Looking at this problem, this is going to need to be solved with the quadratic formula. Also, I didn't even check the other one. I was just trying to practice the quadratic formula. So if I was to make my t-chart, I would get 6, and then I would get 3, so it's just not going to factor. So A is equal to 2, and then B and C are both 3. So that's going to be x is equal to -3 plus or minus 3 squared, which is 9, minus 4 times A times C, all divided by 2A, so 4. So then in the radical, that's going to be 9 minus 4 times 2 is 8. 8 times 3 is 60. Nope, 24. That's -15. So all that comes out from -15 is I. So I write this as x is equal to -3 plus or minus I rad 15, all divided by 4. All right, 70. Well, I'm going to use completing the square on this one because this one is already a perfect square trinomial. So I'm just going to write n minus 2 squared is equal to 0. And then I take the square root. I would normally do plus and minus 0, but that doesn't make any sense. So I just get n minus 2 is equal to 0. And then I add 2. And I get n is equal to 2. And there have to be 2 answers. So multiplicity of 2. So this just means that the vertex would be at 2 if I was to graph this function. All right, 71, much like the problem before where, which problem was it? The one right above it, it's not equal to 0. So I'm going to make this equal to 0 by subtracting 2t and 1 from both sides. Of course, we can't combine them with the 6t because they're not like terms. Like terms have the same exponent and variable. So these have the same variable, but they don't have the same exponent. So I've got -6 and 2, and maybe I'm just not thinking clearly, but that doesn't seem factorable to me. So I'm going to use the quadratic formula again, and I'm going to have 2 plus or minus 2 squared, which is 4, minus 4 times 6 times -1, all divided by 2a, so that's 2 times 6, 12. The 2 negatives inside the radical right there being multiplied are going to change this to 4 plus, and it's 4 times 6, which is 24. So I get 28, and we know 28 is divisible by 4. It's 4 times 7. And we like 4 because we take the square root of 4 and we get 2 rad 7. Oh, geez, so then we're going to have to reduce this. So I'm going to get 2 plus or minus 2 rad 7, all divided by 12. So I'm going to divide by 12 here and then divide by 12 here, giving me 1 plus or minus rad 7, the 2's cancel, all divided by 6. And then this would be my final answer. Really nice. Let's see if there's some easier ones. Yes. I feel like I already did 72. Maybe not. Maybe it was just on our Unit 3 test. So I'm going to try factoring that one. It doesn't have an even middle term, so I won't complete the square. I wanted to add to -7 and multiply to 6. So I want -1 times -6. y squared minus 1y minus 6y plus 6. And then I've got y times y minus 1 minus 6 times y minus 1. And I get y minus 6, equals 0. And then y minus 1 equals 0. In factoring to solve, we said each factor equal to 0. So then I would add 6, add 1, and I get y equals 6 and 1. 73, I just love this problem. We just take the square root. It's w squared. I'm going to cancel that out. So I get w is equal to, I want two answers, plus and minus 12. That's because negative 12 times negative 12 makes positive 144. So we need both of those answers. That one was great. Looking at 74, I wonder if this could factor. So 5 times 6 is 30, and I want it to add to 13. Of course, that's going to be all positives. So I want 10 and 3. I don't want 15 and 2 because it's all positive. That would be 17. This is 13. So 5c squared plus 10c plus 3c plus 6. Then we draw the fence, take out the 5c, and I have c plus 2. Take out the 3, and I have c plus 2. C is a bad letter. It looks like a parenthesis. Then I'm going to set each factor to 0. 5c plus 3 is equal to 0. C plus 2 is equal to 0. Subtracting 2, I get c is equal to negative 2. And then subtracting 3, then dividing by 5, I get the other answer, negative 3 over 5. Beautiful. The next set of questions says something else. What does it say? Oh, these are the polynomials. So these are not quadratics. All the previous had just 2 answers. So I look at the exponent to tell me how many answers I need here. And seeing that in number 75, the exponent is 3, we need 3 solutions. So I have to use that special factoring pattern. And I take the cube root. And it's that SOAP pattern too. Same, opposite, always positive. So I've got y minus 5. And then to generate the trinomial, I multiply y times y, getting y squared. Opposite sign, y times 5. And then it always positive, 5 times 5. So the y minus 5 equals 0. That one's easy. I add 5, and I get my first answer. Y is equal to 5. The other 2 answers are going to be complex, and they always have IRAD 3 in them. We solve them with the quadratic formula. So I'll just do those in pink. That's going to be, in this case, y equals, instead of x equals, negative 5 plus or minus the square root of 5 squared, which is 25, minus 4 times a, which is just 1, times c, which is 25, all divided by 2. So inside the radical, I have 25 minus 4 times 25, or 25 minus 100, which is negative 75. This number is always divisible by 3 if we've done inside the radical correctly for the sum and difference of cubes. This is a difference of cubes because it has a minus sign. So we've got negative 25 here. When I take the square root, this is 5i because it's negative, and then still add 3. So my other 2 answers are that y is equal to negative 5 plus or minus 5i rad 3, all divided by 2. And then I'll just say comma 5 here so I can circle it. All right, the work on 76 is going to be really similar to the quadratics, because looking at 76, we see that every single part has an A. So I take out the A right away, and I'm expecting to get 3 answers here. And I make each part, when I divide the A out, 1 less powerful, so A squared plus 8A minus 33 equals 0. So here's my first factor. I just say A equals 0, and that's it. Now I have this quadratic, A squared plus 8A minus 33 equals 0. I'm going to use factoring. So I've got negative 33, and I've got 8. That's going to be 11 minus 3. Yes, 11 minus 3 would be positive 8 and multiply. So I've got A squared plus 11A minus 3A minus 33. And then I draw the fence. Take out the A plus 11. This is a negative, so take out a negative 3. And then I have A, switch the sign, plus 11. Setting each of these to 0, A minus 3 equals 0. A plus 11 is equal to 0. I get my other 2 answers. A is equal to 0, 3, and negative 11. So I like the ones that have a GCF because they just go back to quadratics and I can factor them. Taking a look at number 77. Okay, this one is a sum of 2 cubes. I see that it's a binomial with exponent of 3. So I take the third root. The binomial is going to say 2x plus 1 because it's the same sign. And then I generate the trinomial with doing 2x times 2x, so 4x squared. Then I need the opposite sign, 2x times 1, and then 1 times 1. So my first answer, 2x plus 1 is equal to 0. I would subtract 1 and then divide by 2. And I get x is equal to negative 1/2. I need that space back. So the other values I'm going to get by using the quadratic formula. So that's going to be x is equal to positive 2 plus or minus 2 squared, which is 4, minus 4 times A times C, which is just 1. So this is 4 minus 16, which is negative 12. Oh, divided by 2A, which is 2 times 4, 8. So this is a sum and difference of cubes, so we take the 3 out, and I have negative 4. And that negative 4 simplifies to 2I rad 3. And wouldn't you know what, we got to reduce this. So I'm going to have 2 plus or minus 2I rad 3. Dividing these by 8. The 2's are both going to turn into a 1. And the 8 will turn into a 4, giving me 1 plus or minus 1I rad 3, all divided by 4. So that one actually counts as 2 solutions, since the one where we add is different than the one where we subtract.
I'm actually standing upstairs. Oh. Did you watch it now or what?
No, I cannot. All right, looking at 78. Oh, I see another GCF, and it's a trinomial, so I feel like that's going to be a nice one. Oh, and I see that the GCF is x squared, because that's the lowest exponent. Oh no. And then I also see that 2, 12, and 40 are all even. So I'm going to take out a 2. So even though this is an equation, I could technically divide everything by the number, like the GCF. I can't do that because there's a variable here and I don't want to lose a solution. This has an exponent of 4 and I want to get 4 answers. So I've got 2x squared as one of the factors. I'm just going to right away say that that's equal to 0. Solving for x, when we divide by 2, it's still 0. And when we take the square root, it's still 0. So we get x is equal to 0, but there were 2 of them. So multiplicity of 2. Now I need to finish the division. So I've got x to the second power, making it 2 less powerful, plus 6x minus 20 is equal to 0. So I'm looking at this and I'm thinking 20, I don't think that that's going to multiply and make, I've got 1 and 20, 2 and 10, 4 and 5. I'm not seeing that add to 6. So I'm going to complete the square. So I add 20, x squared plus 6x plus some special number is equal to 20 plus the special number. And that number is 6 divided by 2 squared, so 3 squared will be x plus 3, and that's going to be 9. 20 plus 9 is 29. So now I get to take the square root of both sides, and I remember to do plus and minus here. This cancels, and I'll subtract 3 to get x is equal to -3 plus or minus rad 29. So I've got 0 multiplicity of 2, that was 2 answers, and then these are 2 more answers. So for a total of 4. Hooray. Okay, looking at 79, that one is totally different type of work because that's it's an exponent of 3. We want 3 answers, but it's a polynomial with 4 terms, not a trinomial. So I just start out by drawing the fence. There's no GCF, so I don't take out a GCF. I get x squared and then 2x plus 5. And then I take out 100. And again, I get 2x plus 5 is equal to 0. So now I'm just going to set each factor equal to 0. X squared plus 100 is equal to 0. And 2x plus 5 is equal to 0. For the first one, we subtract 100. And I've got x squared is equal to -100. And then I take the square root. And I get plus and minus. And since there's a negative in the radical, I comes out. But the square root of 100 is just 10. So I've got I 10, that looks wrong. I say plus or minus 10i. That looks better. So that's 2 solutions. And then the 2x plus 5 gives me my last solution of -5/2. So those are my 3 answers. I liked that I was able to take the square root of the -100. That was fun. All right, looking at 80. The difference of 2 cubes. Okay, we got to take the cube root. This one's going to be a little bit more challenging because there are numbers in both spots. So the cube root of here and the cube root of there. I've got 5x minus 3. And then I generate the trinomial. So to generate the trinomial, I have 5x times 5x, so 25x to the second. I need the opposite sign. And then I do 5x times 3. So 5 times 3 is 15x. And then it's always positive, so 3 times 3 is 9. So setting 5x minus 3 to equal to 0 gives me my first answer. And that would be 3 over 5. And then my other answer is going to come, my other two answers will come from the quadratic formula. So that's x is equal to negative b plus or minus b squared, which is 225, minus 4 times 25 times 9, all divided by 2a, so 50. So multiplying this, we've got 225 minus 4 times 9, 36 times 25. Let's use a calculator. Those are some big numbers. 36 times 25, negative 900. So I get negative 765. Nope, it's negative 675. Now, something that I need to remember from these cube roots is that 3 is always a factor. Dividing this by 3, I get 225, which is wonderful. So then I take the square root of both of these, and from right here, we can see that the square root of negative 225 is going to be 15i, and then we have the rad 3. So putting this all together, I've got negative 15. Oh, I need a little bit more space. I'll put it in pink. So combining this to replace this, I've got negative 15 plus or minus 15i rad 3 over 50. So splitting the 50 up, that way I can divide the top and bottom by 5. That will be 3 and 10, 3 and 10. So negative 3 plus or minus 3i rad 3 over 10 as my other two answers for this one. So super great, wonderful, finished it. The next set of problems says what? Write each equation in vertex form and then state the vertex. Oh, cool. Are these all in standard form? I think they are. So for standard form, we need to know the formula for the vertex is h is equal to negative over 2a. So on h, I'm going to find negative b over 2a. So I've got h is equal to negative 12 over 2, and a is just 1, so just negative 12 over 2. This gives me negative 6. And then to find k, I have to plug that into the equation. K is equal to plugging in negative 6 here. So that's going to be 36. 12 times 6 is 72, so minus 72 minus 7. So adding across, I've got negative 36 minus 7, which is negative 43. So the vertex this time is negative 6, comma, negative 43. We won't be graphing that. That's off the grid. Looking at 82, I don't love it because I see that there's an odd number here. So I'm just going to get a fraction. H is equal to negative b over 2a, so negative 3 again over 2. That's it. So I want to use that as the decimal negative 1.5 to do my calculations because that'll just be a little bit easier for me. So negative 1.5, I'm thinking of that as 15. So 15 squared is 225. So this is my work for k. 225. I add 2 decimal places in. And then 3 times negative 1.5 is going to be a negative number. 3 times 15 is 45. So 4.5. And then plus 9. Right on. So now adding across, I'll just use my calculator to make sure I don't make a mistake with the decimals. And 2.25 minus 4.5 plus 9, I get 6.75. So the vertex here, negative 1.5, comma, checking it again. Does it make sure that it's a positive? Yeah, 9 is pretty big. So 6.75. All right, last one, 83. So the work is going to be the same if it's also in standard form. And it is. So I'm going to do negative b over 2a. It's going to be negative 12. Oh, interesting. They were all positives. So if this had been a negative 12, then it would be positive 12. We have to switch the sign on whatever b is. So starting over, I've got h is equal to negative 12 over 2 times negative 3, which is negative 12 over negative 6. And that's going to be a positive 12 divided by 6, 2. So now plugging this in to find k with the a value is going to be a little bit more challenging. I've got k is equal to negative 3 times 2 squared, which is 4. And then plus 12 times 2, 24, minus 1. No, not that much harder. This is just negative 12 plus 24, which is 12 minus 1, 11. So 2 comma 11. Right on. Now we're on to the graphs. So we've got to look at the graphs and determine their like parent function to help us. So I look at these and I see, oh, okay. 84 and 85, these are both polynomials. They don't have like a parent function exactly. They come from the pattern y equals a parentheses x minus r1, x minus r2 for however many x-intercepts there are. These are for the polynomials. Like that. So in this case, I go to the x-axis and I see negative 2. So y equals a parentheses x minus negative 2, which I will see change to plus 2. And then at that point, we also have to look for the multiplicities. So this is a bounce. It's a vertex happening at that x-intercept. So I give it a 2. And then over here, I'm also at 2, but this one is x minus 2. I just plug in the number. I don't have to change the sign. So this is pretty good. I see that I'm in quadrant 4, which is the negative quadrant. Remember, quadrant 1 is the positive quadrant. So I know that my a value is going to be negative. I just don't know what number it's going to be. So I'm going to use that ordered pair that I just put a dot at. I'll make it pink. That ordered pair is 0, 8. So that's going to be 8 for the y value is equal to a, and then 0 plus 2 is 2 squared, and then 0 minus 2 is negative 2. So I'm just running through plugging in 0 for x. So 2 squared is 4, and then 4 times negative 2 is negative 8. Oh, all this work, and a is equal to negative 1. Because if I divide by negative 8, I just get negative 1. So I've got y is equal to negative, and then x plus 2 to the second power, x minus 2. 85 is also a polynomial, and then looking at that one, we're in quadrant 1, so I know that a is going to be positive. I can also tell that this is an even degree, specifically 4th degree, because both of the ends are pointing in the same direction. So we've got that positive end behavior. Both of the y values are going to positive infinity. So writing the equation, I'm going to use x minus r1, x minus r2 again. So this is like a little bit hard for me to see. Negative 1, 2, 3, 4, 5. Negative 5. Then at 0, we see a bounce. So I'm just going to say 0 squared. And then we're at 1, 2, 3, 4. Okay. So I kind of want a little bit more space just because I write so big. So I'm going to clear this out. Y equals a x plus 5, because minus minus. And then I have x minus 0, which would just be x. That has the multiplicity of 2. And then I have x minus 4. Trying to look for another ordered pair. Oh, your problem is upside down. That's kind of funny. I wonder if I changed it when I was moving, making something bigger. There we go. Let's start it over then. We've got, oh, and then in this case, this would be -4. This is 0 squared, and then this would be +5. So then in that case, we want our a value to be negative because we're again in quadrant 4. So that's going to be y equals a x plus 4, 0 squared, so x squared, and then x minus 5. It's really hard to see another ordered pair that I could plug in. So I guess I'll go with this here, 1, 2. And that would be 2 is equal to a, and then 1 plus 4 is 5. 1 squared is 1, love that. And then 1 minus 5 is -4. So, oh gosh, I've got a times 5 times 1 is just 5 times -4 is -20. It's equal to 2. Dividing by -20, I've got a is equal to -1/10. And that matches what my graph says with it being a negative, which is good. So then plug that in, y equals -1/10, parentheses, I almost put a again, x plus 4, x squared, and then x minus 5. Usually we'll see the x squared as the first one here, but whatever order it's in is totally fine. All right, that was actually pretty fun. It was not as bad as I thought it would be. So 86 and 87, these are totally different. These are the piecewise ones, and I can tell because they start and stop. So on these ones, I always start by finding the inequalities first. So I draw that line to see where they switch. And I can see this first one. I'll do this one in green, left, middle, and then right. So the left function, it's x is less than, and that left function that has the gray dot, that has the closed circle. And the value there is -1. The next one, we'll call it this one here, will be in pink. That one has x is in between two values and it's both open circles. So always do Pac-Man going the same way. The first value is -1 and the second value is +1. And then for the last one, this one, we've got a closed circle again, that's x is greater than or equal to +1, which is nice. And then looking at the equations, I'll start again at the left. This one I'm going up 1 and over 1. And then if I was to cross the y-axis, it would cross right here, and that's at 2. So that's just x plus 2. For the pink function, again, we see that up 1 over 1, which is excellent. That's just x. And we see that it crosses at 3. And then looking at this ice blue one, I again see the slope of up 1 over 1. So that's just x. And then that one, I would go down and backwards. That's +1. So I'm finished. 87 is another piecewise, and it also has 2 rays and a segment. But I'm seeing the left function has the closed circle, the middle function has an open and a closed, and then the last one is open. So let's take a look at that one. So again, I want to kind of sketch to find those boundary values, just to be sure. I just like to do it. So that's -2, and then this is 3. So my first ray will be here. That's going to be x is less than or equal to because of the closed circle, and that value is -2. The middle piece has an open circle on the left, so that's going to be -2 less than x less than or equal to, because there's a closed circle, 3. And then the last function has an open circle, so x is greater than 3 for that one. Okay, now going back to the light blue one, I'll find the slope and the y-intercept. So the slope, here's the 2 ordered pairs. I go down 1 over 2. So down means -1 over 2 x. And if I counted, I would be passing right there. So that's 1, 2, 3, 4. The pink function, I can see the y-intercept, and yep, that one is just x. I don't say +0. You don't have to. And then the green function looks like it's going to be the most challenging. So I see a dot here and here. I count up 3 and over 1. So that's 3x. So then down 3 and over 1. Down 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 and over 1. So I've used counting to find this y-intercept, and it's at -1, 2, 3, 4, 5. All right, that one's finished. So I counted the slope and the y-intercepts. Well, not too bad. Okay, and now we've got just a couple more functions that have been graphed, and each one is special and unique. I can't seem to see 90. I don't know why. Must need to move it up. Okay, there we go. So looking at these, each one of these is made from a different parent function. So looking at 88, that one is a parabola. That's going to come from the quadratic function. It's going to be y equals a x minus h squared plus k. But then I look at 90, and 90 is the snake shape. So 90 is going to come from the cube function, which is y equals a parentheses x minus h to the third power plus k. And then of course, the last one, that's a V shape for absolute values. That's y equals a, I'm not going to write a, it's not a, y equals m, absolute value of x minus h plus k, because absolute value is made up of 2 lines. So this one just has a slope. So finding the hk is, oh, yours is on the positive side for number 90. I wonder how that happened. Yes, okay. Well, let's see if I can rotate this one, because if we want to have the right answer, we want to have the same answers. Like that, probably. Okay. So Now we just find the HK and then we'll calculate another ordered pair to help us find the A value. So in number 88, the HK is the vertex, right? It's the interesting ordered pair. So that's happening at 1, -2. So I've got y equals a x minus 1 squared minus 2. I just realized I didn't put some of those functions into vertex form. Oh no. Now I see an ordered pair and I've got 0, 0. I'm going to use 0, 2. I'm sorry, 2, 0. So that's 2 for x and 0 for y. So I've got 0 is equal to a times, I've got 2 minus 1 squared minus 2. So now I'm going to solve for a. So I'm going to add 2 to both sides. It's going to give me 2 is equal to a times 2 minus 1 is 1. 1 squared is 1. So, 1a is equal to 2. A is just equal to 2. So then when I go into this, I can just change that to the number 2. And that's my final answer. Wonderful. For number 90, I see the HK there, and it's still different. Well, I'll go to 89 first. I'll see if I can work on this one in a sec. Maybe it's like, it can't be another way. I don't know. So for 89, I find the HK, it's the vertex again. So the vertex here is, this is the origin. It's 3, 1. And so that's just y equals m x minus 3 plus 1. Love that. And then the slope is up 1 over 1. So I actually don't need an m here at all. It's just like this. That's the final answer. So I love absolute value because we don't have to do the work like we have to do in 88 and 89. So then let's clear this out. I'm going to try to adjust 90 so that it matches. I have a PDF version of this, so I can actually access that. It's downloads. First semester final review. And all the way down here. Okay, so this is what I hope it looks like for you. I don't know where it just went. I zoomed in really well. Okay, great. Where is it? So I see in HK form, the cubic function, the HK is that inflection point. So the HK, wherever it is, right, we find it, it's the turning point for this function. So I'm going to have y equals a, x minus h to the third power plus k. And this point here is at negative 1, 2, 3, 4, 5, 6, and negative 1. So I've got y equals a, x minus negative 6 will be plus 6 minus 1. And then I see that these ordered pairs are pretty bold. This one here, it looks easier to find. -5 and +1. So when I replace the y value, I've got 1 is equal to a. X value is 5 plus 6. Oh man. It's -5. There we go. -5 plus 6 to the third power minus 1. So that's much better. I did not want to do 11 to the third power. So here I've got a. -5 plus 6 is just 1 to the third power, so that's just 1. Minus 1 is equal to 1. So adding 1, I get a is equal to 2. And replacing the 2, I've got my final answer. So that's that. Very cool. Are there questions that you want me to go over if you are here right now that you missed me going over because you did? 77, sure. So 77. Going to be right here. All right, so 77 is the sum of 2 cubes. And so that's the one where we've got to have that special factoring pattern where we take the cube root. And then we'll do 34 and 46 after. So when I take the cube root, I get 2x. And then of course, cube root of 1 is just plus 1. So I factor that, and then I factor the other side using that factor pattern with the happy face and the acronym same, opposite, always positive. So 2x times 2x is actually 4x squared. Then the opposite sign would be minus. And then I do 2x times 1, which is just 2x. And then finally I do 1 times 1, which is always positive, and that's 1. Because I'm solving this, I now set each of these equal to 0. And the first one, 2x plus 1 equals 0, I minus 1. And then I divide by 2. That's my first answer. The other answer comes from the quadratic formula. 2 plus or minus 4 minus 4 times 4, all divided by 8, which is -12, which becomes -4 times 3. When I simplify the radical, and that's how I get 2i rad 3. So then seeing that I've got to divide this, I've got 2 plus or minus 2i rad 3 over 8 and over 8. And then dividing everything by 2, I get 1 and 4 and 1 and 4, giving me my final answer of x is equal to 1 plus or minus I rad 3 over 4 and the -1/2.
Dad, quiet. Shut up.
All right, for 34, and then I'll go to 46, and then the other question for this segment. Okay, 34. Oh, we're getting so close to 34. Okay, 34, this is super fun. So I look at 34 and I see that this is a binomial and the exponent is even. So this is the difference of 2 squares. I start by taking the square root, and this is that fun plus minus pattern. Much easier than the sum and difference of cubes. So when it's a square power, even power, we just take the square root. That gives me x to the second plus 4, and then x to the second minus 4. So this part here does not factor further. The sum of 2 squares isn't factorable, but then this one here is factorable again. It's a chain reaction. So I factor that to, I still have the x squared plus 4. And then taking the square root again, I get x plus 2 and then x minus 2. Final answer. Then for 46, is a quadratic in intercept form. So when I see this one, I think, okay, I just need to find the two x-intercepts, and that will help me find the vertex. So this is an intercept form, just meaning that it's a x minus r1, x minus r2. So the intercepts are going to be 4 and 2. 4 and 2. So if those are the intercepts, this is a parabola. So we can tell the midpoint between them is going to be the axis of symmetry. Visually, we see that the midpoint is right here. We also have that formula r1 plus r2 divided by 2, which would be 4 plus 2 divided by 2, which is 6 divided by 2, which is 3. Whichever way works for you. So now that I have that the number is 3, I've plugged that in to find the vertex. So that's 1/2, 3 minus 4, 3 minus 2. So that's going to be 1/2 of -1 times 1. So that ends up just being -1/2, which is -0.5, which is just easier for me to graph right here. So that's okay. I also want to find the y-intercept just to help me graph this better. So the y-intercept is what I'm going to just plug in 0. So that's going to be -4 and then -2. When I change the x value to 0, ooh, I have a negative times a negative. So this will be a positive. 4 times 2 is 8, and 1/2 of 8 is 4. So I get 0,4. Then I'm also going to use the symmetry here. This is 3 units away from the axis, so 3 units the other way to plot a one more ordered pair. And then I graph it. The important thing to know is that those are the x-intercepts. I don't know if there was any extra like askings on this, like if they asked me about anything. Okay, domain, range, minimum, and maximum. So, so the domain is all real numbers. We say -infinity to infinity. The range is not all real numbers. The range starts here, and that was at -0.5. And then it goes to positive infinity. These arrows are pointing up. Another way we can say that is y is greater than or equal to -0.5. The y values are all above -0.5. Which just means that -0.5 is the minimum value. We found the x-intercepts already. We found the y-intercept. We've got the domain and range. So we want the increasing and decreasing intervals. So for those, I always draw a line through the axis of symmetry. And I just label it. This was 3 here, 3 here. And then along the x-axis, I label the negative infinity and positive infinity. So these are the two answers. So the increasing interval and the decreasing interval. I just don't know which one's which. So when I trace this side is going down. So the decreasing interval is -infinity to 3. And the increasing interval is 3 to infinity. And then is this 1 to 1? No. No parabola is going to be 1 to 1. Great. And then it was so that's 46, 86, and then back to 40, and then 51. So 86. 86 is way down back at the bottom. So to get the x plus 3 for this segment, we have to count the slope. 86 is right here. So the segment, I'm counting this. I see that I go up 1 and over 1, up 1 over 1. So that means that the slope is 1. And then this value here where it crosses the y-axis is the b value, and that's 3. So wherever it crosses the y-axis is the b value. So that's why on the other ones I had to count. So like on this one I counted and it would be here. And then on the other one I counted and it would actually be somewhere else. So they all have different y-intercepts. All of these had the same slope. So I just counted the slope up 1 over 1. Make sure to count through a specific ordered pair that you can see. And then coming back to number 40. 40 was close to where we were before, but just going in the order that they were asked. No, 40. Here's 40. Okay, so 40 says graph this ray or segment. So looking at the equation, I see that it's something kind of weird. It's 1/3 x plus 4, and then I've got the y minus 3. That's kind of funky. So right away, I see that this is x is less than or equal to -1. So on my graph, your graph is probably better. I go to -1 for x, which is here, and then I'm going to draw the closed circle and then the arrow pointing in that direction. So that's the shape that's going to go on the graph. I just need to know where to place it and what the slope is. So I need to plug in this number because that's where that closed circle is going to go. I'm going to plug it into this equation. So I wanted to say y equals. So I'm going to add 3. Oh no, I hate that. I'm going to add 3 to both sides. So it's going to be y equals, this is gone, 1/3 parentheses x plus 4. I can't add the 3 inside parentheses. That's not allowed. It's plus 3. So I'm plugging in the -1 to this equation. 1/3 -1 plus 4 plus 3. No, so -1 plus 4 is 3. 1/3 of 3. That's 3 divided by 3. The 3's cancel and I have 1 plus 3, which is 4. All that work to say -1 comma 4. So back onto the graph, -1 comma 4 is where I put the closed circle. That's where I start. -1 comma 4. And then the slope is 1/3. So that's an equation that's in point slope form. You might remember that from algebra 1. So it's the slope is 1/3. That's important to know. So if I want to graph the slope, watch this. So I'm back on my grid and I'm trying to follow the line that I showed, right? I need to go this direction. So I can't go up 1 and over 3. I go down 1 and backwards 3, down 1 and backwards 3. That's all I got to do. Of course, when I use the PDF, my computer glitches. But that's that for that one. Use the slope. Make sure to start with the number that's shown. That will help you. All right, 51. 51. All right, so this one is a cubic function. You can tell by the third power. And I want to remember my cubic function has the parent t table. -8, -1, 0, 1, and 8. And I make that transformation table x plus h, ay plus k. So this one will be, okay, the a is equal to -1/2. The hk is 3, 4. So x plus 3, the -1/2 y plus 4. So that's gonna be, I take these x values here and I add 3 to them. So -2 plus 3, 1, -1 plus 3 is 2, 0 plus 3, 1 plus 3, 2 plus 3. And then I take the y values and I do the same thing, except for it's half y plus 4. So -8 times -1/2 is +4, plus 4 is 8. And then -1 times -1/2 is +0.5 plus 4 is 4.5. And then 4, and then 3.5, and then 0. So these are the specific ordered pairs to graph. Also want to find, if possible, oh, sweet, here's the x-intercept. I want to find the y-intercept while I'm sitting here doing work. So that's going to be -1/2. I plug in 0, so -3 to the third power plus 4. So -1/2 times -27 plus 4. Those two negatives cancel out, and I have 27 divided by 2, 13.5 plus 4, just 17.5. So off the graph, I won't need it to do my graphing. And then for increasing and decreasing, I can tell based on the a value that this function is only going to decrease because these functions, the snake shape, only go in one direction. This is what it looks like when it's positive, going up. So with a negative a value, we want to talk about the transformations. The a value is negative, so that's called a reflection over the x-axis. The a value is also a fraction. So the fraction also does a different thing that the reflection didn't do. So flipping it over, but then the fraction also squishes it. So that's a compress by the factor of 1/2. Then we talk about h and k. So +3 means we move to the right 3. And we just say left or right for h. And then for k, that's 4, we say up 4. So I love doing those transformations because they seem a little bit easy. And then is this function 1-to-1? Yes, all these h form cubic functions are 1-to-1. So now I just want to graph these values. And I start with 1, 8. So I need the space back. Okay. 1, 8, 2, 4.5, 3, 4, 4, 3.5, and then 5, 0. And then this one has a domain of all real numbers. And it has a range of all real numbers, which we say -infinity to infinity when we're using interval notation. We won't have to do that on our test. And then which did I miss? Increasing and decreasing. So this one just has the decreasing interval. and no increasing interval. So those are all the ones that you guys have asked for, which is great. So I guess I'll see you guys later.